The sonic dimension of ecosystems has been explored, and a number of systems are dedicated to making these ecosystems audible. Some systems have explored the idea of sound-making agents in virtual ecosystems. From birds singing to cricket chirping, nature has evolved some of the most intricate sonic forms. It provides much inspiration for artistic exploration. In Listening Sky from 2001 by Alan Doran, singing agents mate based on their musical mating calls. Agents roam a virtual globe, searching for mates and playing musical patterns. Agents prefer mates that have bodies in their favorite colors and that sound pleasing to their personal musical tastes. The audience member controls a listener that hovers above the globe, eavesdropping on the local populations of agents, exploring the dynamic soundscape that evolves. Let's listen to a short excerpt of a possible result. Peter Todd and Gregory Werner developed ecosystems inspired by the natural evolution of bird singing, in which male and female agents evolve melodies that stand as love songs. In this system, the females are initialized with a transition matrix based on existing folk songs melodies. They evaluate the male-produced love songs based on various criteria, including local node-to-node interval transition preferences, global transition preferences in which the transition matrix of the song heard is compared with the transition matrix of the female agent, as well as surprise, which means that rarely seen transitions are valued. Offsprings are then generated by crossover and mutation of the two genomes using a transition table. Similarly, Dastel and Nordahl 2001 system Living Melodies is made of agents that co-evolve sonic communication. Each individual has both a sound genome made of short melodies up to 10 notes and a procedural genome that is evolved using genetic programming with a set of possible actions such as walk, turn, rest, sing, and loop with conditionals to structure those actions into decision trees. This genome encodes the behavior of the agents. Non-Darwinian variations of evolutionary computation have also been explored. Eduardo Miranda and his colleagues have developed the RGIM systems between 2005 and 2007. RGIM stands for Rhythmic Meme Generator and was inspired by memetics, which is the study of the propagation and evolution of memes that serve as mental content for the agents and constitute culture. A few years later, in 2010, they developed IMAP, which stands for Imitative Multi-Agent Performer, to tackle the problem of interpretation. Musical interpretation is the problem of producing an expressive rendering of a composition through all the performance strategies that are not explicitly specified in the score or composition. Interpretation includes all the nuances of timing, velocity, and so forth. The IMAP system uses imitative behavior that spreads and reproduces through the population of agents to produce the interpretive performance. Finally, GeneSense from 2013 is a simple ecosystem in which Boyd's agents evolve while trying to gather ambrosia, the resource that they need to survive. Here is a short example of GeneSense in action. Ecosystems do not have to be visualized, and some systems and pieces have explored purely musical, purely sonic agents. Gary Nelson in 1993 with the system Sonomorphs did just that, as well as the piece In Vitro by Michael Malt from the Institute for Research and Coordination in Acoustic and Music in 2001. in which each reactive agent is a musical phrase on a two-dimensional space with local perception and behavioral rules. A 2009 version of the rhythmic generation multi-agent systems kinetic engine by Arne Engelfeld is using evolutionary computation in an original way. Engelfeld considers the population of rhythm to be the memory of the agents. Initialized with rhythm resulting from the analysis of Afro-Cuban music, the system is let loose and agents evolve rhythm in addition to the complex sets of action and perception feedback loops typical of multi-agent ecosystems. The output is recorded through a music notation software, and the resulting composition is titled Amar and is a 4-movement piece for percussionists. Let's watch an excerpt of its performance. While there are fewer examples of audio or musical games using virtual ecosystems, Electroplankton is one exception to this rule. Electroplankton is a 2005 game by Nintendo that allows the player to interact with animated plankton to create electronic music through one of 10 different plankton-themed interfaces. In conclusion, the artificial life paradigm calls for a different vision, using evolution, coevolution, and self-organization to implicitly define the fitness function that governs the survival and evolution of the system. When made interactive, these evolutionary ecosystems propose a radical change to the human-machine interface. The system becomes a hybrid ecosystem in which the virtual environment is no longer a static system driven by a static set of rules, but a changing, evolving entity that we can interact with. For all those reasons, virtual ecosystems are one of the most exciting sandboxes for artists to explore. These digital aquariums of artificial life allows us to observe the generative evolutionary processes in action. But their implicit fitness function and closed-world evolution can result in musical content that is disconnected from the human experience. Indeed, evolutionary ecosystems in which artworks are generated can be said to develop new aesthetics evaluation metrics. These metrics are valid within the system, but do not necessarily make sense from outside the system. In other words, the aesthetic values evolved within these systems do not match that of humans, since it has evolved in a different context. In most cases, these aesthetic standards created by agents are alien to us. On the positive side, these systems certainly provide insight into the evolutionary process and serve as excellent educational tools.